So what is MDX? The acronym MDX stands for Multidimensional Expression Language. This is the query language for a multidimensional cube in Analysis Services 2014. The query language was created and standardized for OLAP systems, not just for Microsoft, but any vendor that uses OLAP. The standard has been in use for over a decade. Within the context of a multidimensional cube, MDX can be used in various areas. The first one you'll see more frequently is the cube calculations. And within those calculations, you can have named sets. Also, key performance indicators use MDX in different areas, including the trend and display values. And lastly, the reporting systems can use MDX to return a data set. Security, which is role-based security, can use MDX to filter on certain attribute member data. So let's understand the structure of a multidimensional cube. First, we'll look at object names. The multidimensional cube starts at the cube level. In the display in your right, you can see an intersection of 2, 3, 4. In three-dimensional space, this is a point in that cube. It's the same way with multidimensional cubes, except usually you have more than 3 dimensions, so it's hard to visually see the intersection. But when you see something like 2, 3, 4, maybe even with a comma 1, you know that's an intersection in n-dimension space. This is the container, a cube, of the OLAP data, and it was compiled like we did in previous sections of this training. This structure contains all levels of metadata, which is data about data, and the actual data itself. The dimension object is where the slicing and dicing or display of attributes and hierarchies happens. The hierarchies have multiple levels, but if you remember, an attribute is a hierarchy and also has at least 2 levels unless specified not to. And those 2 levels are the all level and then the member data of the attributes. Member data is the leaf level of an attribute rather than in hierarchies or not. They can be referenced by a key value or the display value. To your right, you can see the calendar dimension and the calendar hierarchy. And then under members, you'll see all periods and then the calendar years. When you drill into a calendar year, you see the half year, then the quarter 1, and then the months January, February, and March. This is member data at different levels within a hierarchy. The measures are actually within measure groups, but it is actually a dimension when it comes to querying with MDX. The measures are organized into these measure groups, which are actually aggregates from a fact table. Even though a measure is displayed and acts like a dimension, there is no leaf level or member name at the end to display. Rather, when you reference the name of the measure, you get the aggregate returned based on the selection of dimensions picked. You have to use the reference in an MDX query to get the results, and these results are aggregations. So let's look at a demonstration on using MDX to query data. First, we're going to launch SQL Server Management Studio, either from an icon or on our desktop or from the Start menu. Once we launch that, it's going to want us to connect to a cube that we've already compiled. But first, we have to pick the instance that we want to connect to. Then we can drill into databases just like the database services and select one of the analysis services databases to work with. Then we'll create a new query window, and in the meantime I'm going to hide that Object Explorer to our left. If you notice, there is a list under measure groups of all the measures, KPIs, and dimensions. So when creating MDX, within Management Studio, you have lots of help even though there's no IntelliSense. What we're going to first start doing is writing some basic queries. I'm going to type select, hit the enter key, space out and type from, and then drag the cube name to the from clause. When I execute this, there's actually a value that is returned. What this value is actually the default measure for the cube. In this case, it's a count of sales line items. So, without specifying anything other than a select, from, and cube name, we can actually get the results. This is interesting because in T-SQL you don't get this kind of behavior. But the whole point of an analysis services cube is to define everything in your ETL, select it together, and get it compiled into a data set that will always return you results, where you don't have to put logic in there to remove or add things to the T-SQL statement. So let's browse a little bit around the Object Explorer to our left to see what we have. Now, what you'll see under Measures are the actual measure groups, and then when you drill into the measure groups, you see the measures. You're able to drag and drop one of these measures to your select statement. So if I drag internet sales to my select, I need one more thing before I can use it. I have to tell it that this is on the columns. I have to specify what level I want to display it in an MDX. If I execute this query, now that default measure count is no longer used, but the internet sales amount is summed up for the entire database. An interesting thing is there are many properties behind a measure or dimension. If we double click that value, we get a cell property that tells us an ordinal value, a value, and then a format value. And these are the default properties in an MDX query. You can add different cell properties if you'd like to be returned to your reporting tool. This shows the power of MDX. Let's cancel this and go back to our Object Explorer, and let's zip up the measures and then look at KPIs. KPI for our gross profit margin has a value, goal, status, and trend, and we can use all these in our MDX query. Let's look at order date. Order date is where our attributes are listed at, and if we go to the very first one, date, drill into it, we see a level called members. And if we drill into that members, we'll see all. But let's go one step further and go to the date level of the date attribute. If we drill there, we'll see that there are no members but the actual member values. You don't see the all level there. But if we go back to all, drill into it, we'll see those date values. This is very important when referencing an attribute and what level you pick. If you pick the higher level, you will get the all member. If you pick the level below that, you actually get the date values. And a very important thing to remember or know where to reference. We'll also see our hierarchy, which has a little pyramid icon next to it. When we drill into it, we can see the different levels of year, quarter, month, and date. So the hierarchy can actually reference any of those member data at that calendar date level. But if we drill into members like we did with date, we will see the all level. All would be all years. Under all, we'd get our calendar years, then our quarters, and then our months, and then our days. So you can reference any one of these levels. Let's look at one more thing, and we'll drill back up on our date, and we'll go to the product dimension. So currently, our MDX query lists the internet sales for the entire cube. Let's place a comma next to on columns, hit the enter key, space out some, put on rows, and now we have our second level of the dimension. Now we can drag and drop different items into our query. Let's drill into category, to members and all, and let's drag the bikes. Now watch what happens when we drag that out there. it's going to actually reference the point or ordinal position of bikes, and it prefaces it with an ampersand. So you can actually reference the integer value that's behind a particular attribute. What's easier to do is to actually type the value itself. So if you notice here, we're not saying something like where product category equals bikes. We actually reference the member data inside the query. Now if we run this query, we'll see the value returned. I'm also going to copy this query, put a go at the end, and put in the second one that ordinal position, and run both of them. And you see the same thing is returned for both. The display value is bikes and not 1. But you can also reference it as bikes itself. That is a very basic type query, and you can see how dragging and dropping these items can give you some results. The last thing we'll look at before we continue is the where clause. I'm going to go ahead and remove the bottom query, and now we're going to add a where clause to this. Now what I want to do is just to look at 2011 bike sales. So I'm going to go to my order date, to my year attribute, drill into members, all, and find 2011. When I drag it out, I get that ampersand 2001, which the key value in this case is the exact same thing as the display value. But when you build a cube, this can be different. So my where clause actually references that particular member data, and if I run it, you'll see it'll change from 28 million to a smaller value. And that becomes 7 million. Now what you don't see in here is the display that it is 2011. That's not visible because we haven't created what's called a tuple yet, which does an intersection of different attributes. We'll do that in the next section. But remember, this is a very simple query, and it seems like T-SQL, but there's some caveats. The on rows and on columns, the from a cube rather than a table, and the where clause that actually references the member data at an exact point. Remember, all this helps you build and build on the MDX language, which you'll see will come to play in calculations, KPIs, and even security. So let's talk about members, tuples, and sets. The member.value and the member key, as well as the value of these dimension attributes. A member is either a key value or display value for the level specified in either a dimension hierarchy or a dimension attribute. Remember, an attribute is a hierarchy with an all level and then member levels. This is different than T-SQL because you specify it more often in MDX than in T-SQL. This is a function to return all or certain members, which may be sliced, which we'll look at later. Once you have a member in place in a row or column, you can intersect with a measure name and create what's called a tuple. This is the intersection of the member and measure value, and that measure value is usually an aggregate like a sum or a count. Here in the example to the right, you see in the columns we have sales amount, where in the rows we look at the non-empty values of calendar year dot members. The members function will return all values of that intersection for calendar year that don't have empty values for sales amount. When you combine tuples together, you end up with a set, and you can see the set is surrounded by curly brackets and the tuple is surrounded by parentheses. In the example to the right, you see category 4 with sales amount and category 3 with sales amount surrounded by the curly brackets. This creates two tuples which are made into one set. When viewing a member, you see the data at the level of the dimension. As you see in this listing on the right, we drilled into geography to get the members of region. The top is the all, then we see Australia, Canada, and other countries. Remember, All attributes are hierarchies. There's always an all level unless you specified in the cube not to have an all level. And if you don't have an all level, then there has to be a default dimension attribute member data selected. By creating a query window for MDX connected to a cube, you can browse in the left these member values at all levels, and even drag and drop them to the query window. The member values will be replaced with a key value when you drag and drop. If the key value is different than the name property, you can actually change it yourself. You might have to manually change this from an ampersand to the actual value. It's clearer and better documented when you use the value rather than the ordinal position. The difference from T-SQL becomes obvious. T-SQL doesn't see a value in the query till the query is run for you, like your dimensions or attributes, or in that case the columns. While cubes have values for the member data, the results from the query will be measure values, and the member data becomes column and or row levels. Let's talk about tuples, which is the intersection of dimension. Tuples are the intersection of the n space in a cube along with at least one measure. As you can see in this example, the where clause contains the tuple. All possible dimensions are listed inside of here. You can see order date year is 2011, but the product category, customer PO number, and customer are at the all level. This intersects all those dimensions while trying to find internet sales. All possible dimensions can be listed with a reference to the all level of the hierarchy or attribute. In our case, the order date, though, is the slicer with year 2011. You can include all for a tuple or exclude it. The cube knows how to use the all if none is specified. So in this from clause where we just specify order date.year.2011, the cube knows to go find the all levels of the other dimensions, intersect all that data to return internet sales. So that's a shortcut so you don't have to specify every dimension attribute with the all level. Finally, you want to surround it by parentheses to indicate that that's a tuple, and it'll help with self-documenting of an MDX query. A set is a collection of tuples that are surrounded by curly brackets. This expands our MDX knowledge and helps us set up to use set-based functions later on those returned sales. Sets can be saved in a cube in the calculation section under named sets. Where a tuple returns a cell, the set returns multiple cells, as you see in the example in the upper right. We have the internet sales for bikes in 2011, clothing for 2012, and accessories for 2012. Then there's an indication that there are no internet sales for components in 2013. The product by internet sales can actually be saved in a cube as a named set where you want to see something like the top 5 product categories by internet sales. An important part is in the dimension hierarchies, they have to be the same. You cannot mix these together, and this is called shared hierarchiality. The same dimension has to be referenced, like in this example in the set and the curly brackets and the tuples with the parentheses. We have product category first, comma, the year of order date. We actually have to have product category in each tuple in order to make it a named set. The same thing for order date year. If we were to change something in there or reverse the order where some have order date year first and product category second, you will get an error. So this is a properly formatted MDX query for the intersection of tuples for a set. You can't mix these together, and in this example you'll see that it returns an error because we mix subcategory with category in the product dimension. It's going to return an error saying members, tuples, or sets must be the same hierarchies in the function. Now if you have a hierarchy that has both of those attributes in them, you can reference that, and we'll see that in the demo. In this section, we're going to start looking at some functions that are available with MDX. Functions are used when specific member data is not known, or you're trying to dynamically get the data or members, and if that is necessary, you must first use what's called a member function, and it belongs to the attributes or hierarchies of a dimension. Here we can get a list of members from the hierarchy or attribute in the hierarchy. Members is not the only function used at this level. There are many properties to this level that are functions. The non-empty wrapper will help us clean up the data, or if no data is returned, give us the substitute for it. Cross-join enables two different sets of tuples to be combined and form more complex tuples, which are now sets. Time intelligence functions helps with the creating of trends by looking at a previous period or some to-date summations like year-to-date or month-to-date. Then we have hierarchies, and we can use ancestor-type functions to look at things like siblings, descendants, cousins, and many more based on the hierarchy itself. The example to the right shows the use of the parent function of the current member. The members function will return a set of tuples. The syntax is like the following, where .members is placed at the end of a reference to a hierarchy of a dimension or a level of the hierarchy, which are the attributes in the hierarchy. The all member and members will be returned if you are at the higher level in the hierarchy. The list of members are converted to a tuple before displaying. The group of tuples from the members function forms a set. You can use other filters or slicers to limit the members that are returned with the member function. Using the members function on the hierarchy level will return the all level plus the member data levels. Again, remember, an attribute of a dimension is a hierarchy. In this example, you can see the all plus product categories of the product dimension for internet sales amount. Once we reference the member function for the attribute level, and in this example you see product.product category, which is hierarchy, dot product category, which is attribute in the product category hierarchies, and then the use of the members function. In this case, the all is not returned. Wrapping the non-empty around the set helps filter non-null values or results only. This comes in handy when a dimension like date has value in previous years that do not have related measures in a particular fact. You can't remove the dates for the dimension because other facts need those dates. So let's look at a demonstration of the members function as well as non-empty and the others that we'll be using throughout this MDX training. First, we'll start by launching SQL Server Management Studio. I'm going to do that through an icon on my desktop, but you might have to go to the Start menu in order to launch it. Once it comes up, we'll connect to our default instance for analysis services, and then we'll drill into the databases and go to the AdventureWorks DW 2014. We'll click New Query to create a new query window, and it'll hide the Object Explorer. The first thing we're going to do is look at the members inside of some dimensions. We're going to drill into the product dimension and then product category, and you'll see that there's two different levels. If we hover over product category, it'll tell us we're at the product.product category level, which is the hierarchy. But if we go to the product category attribute in that hierarchy, we can see it drills a little bit further. And again, you'll see the members and the all for the hierarchy, and then you'll see the members, which are actual values in the product category. Remember, an attribute in a dimension is a hierarchy and will have an all level if specified. I can drag this out and use it as part of my select statement. I'm going to drop it to the second line, and on the first line I'm going to type select, and then I'm going to drill into measures and then internet sales. Here I'm going to drag the sales amount and I'm going to put that on my columns. Put a comma there, space out, and then our product category all will be on our rows. Last thing I need is a from clause, and I can drag the cube name out onto the query. If we launch that, we should see the all value for our sales amount. Now let's change the all to members. Now we're using a function of the product category hierarchy to return all members of that particular attribute hierarchy. And here we see the all, bikes, and unknown. We can also put the non-empty on here and get just the list of non-empty product categories. I'm going to go ahead and put a squirrely bracket before the product and also a parentheses. Remember, this designates a set and the parentheses designates a tuple. The members function will return a set of tuples. So I'll close my tuple and close my set and then close my non-empty. And if we launch that, we'll see components and unknown are now no longer in there. The last thing we'll do is add the product category attribute to this reference, and then we will no longer have the all member. We'll just have bikes, clothing, and accessories. So now let's look a little more about tuples. I'm going to open a previously created query file, and we're going to look at how to specify a tuple. I'm going to go ahead and comment out the bottom part just so it doesn't run right now. And we will see that we can actually specify a tuple in the where clause. Here, the tuple is the intersection of 2011 and order date, all from the product category, all from the customer PO number, and all from customer. So here we have the intersection of all for the dimensions and also just 2011, and what we have in the select is our internet sales. So if we run this query, we'll see the result for 2011. Now, you can actually take a shortcut here by removing all the references to the all, where the only thing in our where clause is the year 2011. This is for demonstration purposes only, and just so you understand what the tuple really is. So if we launch this, we should get that same 7,075,525, which we do. So here's an example of using a tuple in the where clause to actually filter or slice the internet sales amount. The next thing we're going to look at is more of an intersection of tuples, and we'll do this within the select statement itself. We'll also open another file that was previously created to help us along. So here, I'll comment out the bottom part just so it's not going to execute, and we'll use it later for reference. But we're going to select the internet sales amount on our columns, and then we're going to create a set with some tuples. Our tuples here are the intersection of a category and a year. We can see that in our first one. We separate it by a comma, and then we're going with clothing for that same year. Separated by a comma, open parentheses, and then we're also intersecting the clothing for a second year. So here you can see the intersection of multiple tuples that form a set. Let's go ahead and execute the select statement, and you will see the bikes for 2011 and the amount. You'll see clothing for 2011, which is null, but for clothing for 2012, you see $642.79. So this is the intersection of two different attribute members inside the rows, which form multiple tuples. And by combining them together, we get a set of tuples. Now, let's look at what can be a problem with this. And I'm going to grab the next query and replace the current one with it. Here we intersected the product category with a product subcategory. When we try to run this, it's going to tell us that the members, tuples, or sets must be the same hierarchies. We cannot combine the product subcategory with the product category because that is two separate hierarchies. But there's another way we can do this. I'm going to grab this next query. In the next query, what we do is we actually separate the product category and product subcategory into the products by category hierarchy. So if you remember, in the products dimension, there's the individual attributes, but we put them in a hierarchy here as called product category. Now if we drill into this, you see that the products by category hierarchy has members, and it has an all level, then a category, then under a category, a subcategory. So now these two are actually combined into the same hierarchy. You'll also see that the attributes under those hierarchies have members as well. So here we're actually able to reference subcategories and categories together. And when we execute this query, we'll see now that mountain bikes, which is a subcategory, can be combined with the categories. This is an example of a good reason to actually have the attribute still in the dimension, but yet part of a hierarchy. You can even have the attribute hidden and still be able to reference it in an MDX statement. This shows the power of the members function, the tuples, as well as set-based functions. And because we're returning cells instead of one cell, now we can perform functions on that as well.